Okay, here we are getting close to the end of chapter 4, and today we're on notes number 22. We have kind of a potpourri of things to go over today at the end of the chapter. We're going to learn how to solve quadratic inequalities. We're also going to learn what you do if you have 3 points and you want to fit them to a quadratic function. And then we're going to take a look at quadratic regression. So you might have remembered linear regression that we did with our calculators. So quadratic regression is very similar. Okay, we're going to start with solving quadratic inequalities. But for a little bit of background, I want to remind you how we solve a linear inequality. So let's take a look at number 1. So basically, we're just going to solve this like we would an equation with one exception. And the exception is if you multiply or divide by a negative, you switch the sign or flip the sign or reverse the sign, however you like to say it. So in this one, I'm going to add 5 to both sides, and we have 3x is less than 12. And then divide both sides by 3. Now 3 is positive, so I don't need to flip the sign. So I just get x is less than 4. And then we can graph that on a number line. For less than, we have an open circle and arrow to the left. Okay, now you need to know that solving a quadratic inequality is quite a bit different. It's not just a matter of remembering one little thing and flipping the sign. Because if you have a quadratic, if you think about this visually, if you have a parabola, and essentially what you want to know is where is it positive or negative, there may be 2 areas where it's positive and 1 area where it's negative, or it could be the other way around, or maybe it's always positive or always negative. So we're going to have to divide it into sections. And we divide it into sections by first figuring out where does it equal 0. And so I'm going to teach you a method called the critical point method, which starts by finding where it equals 0 and then dividing it into sections that we call intervals and testing each one. Okay, so we'll do this problem first. X squared plus 2x is greater than or equal to 8, and we're calling this method the critical point method. So I'm going to describe the steps to you. So the first thing you need, because you're interested in knowing where something is positive, which would be greater than 0, and where something is negative, which would be less than 0, we need this to have a 0 right here. So if it's not already a 0, let's subtract 8 from both sides. And now we have x squared plus 2x minus 8 is greater than or equal to 0. Now to find the points where it equals 0, we're going to take this and set it equal to 0. So I'm going to call that my first step. Set it equal to 0. X squared plus 2x minus 8 equals 0. And then we're going to solve for what we call the critical points. Solve for, sometimes they're called critical numbers, sometimes they're called critical points. These are the points that make it equal to 0. So here we have a quadratic equation. We know all different ways to solve it, and possibly you could solve it by factoring. I think this one we can, so let's go with that. If you can solve it by factoring, it makes this kind of problem much easier. So that factors into x plus 4 times x minus 2. We'll set each factor equal to 0 and solve each one. And we get x equals negative 4, and we get x equals 2. So those are known as the critical points. Okay, so from here what we do is we take our number line of all real numbers. I'm going to just draw the number line as a visual. You don't really have to draw it. But the number line goes from negative infinity to infinity. And the critical points are where we're going to split the number line. So make a split at negative 4 and make a split at 2. And what this does is it creates 3 intervals. So step 3 is to create intervals. So we have an interval from negative infinity to negative 4. We have an interval from negative 4 to 2. And we have an interval from 2 to infinity. So what we're going to do with these intervals is we're going to pick a point in each interval and test it to see if we get a positive or negative for our inequality. So I'm going to write that step 4 down here. Test a point in each interval. This feels like a lot right now, but once you get the hang of it, it's not going to take so much time. So let's see. I'm going to test x equals -5, x equals 0, and x equals 3. You can choose whatever you want, just don't choose an endpoint of the interval. So where do I test it? Testing it means plugging it into the equation, plugging it into the factors right here to see if they turn out to be positive or negative. If you have factors, that's the easiest way to do it. So let's take -5, our first test number, plug it in for x into the first factor. -5 plus 4 is negative. That's all we need to know. We don't need to know the number, we just need to know it's negative. And then plug -5 into the second factor. -5 minus 2 is negative. Negative times negative is positive. So that was our test. We're going to analyze the results in just a minute. Let's move on to the second number, x equals 0. Substitute it into the first factor, 0 plus 4 is positive, and substitute it into the second factor, 0 minus 2 is negative. Positive times negative is negative. Same thing for x equals 3, and we get a positive times a positive, which is positive. Okay, so now we need to analyze the results and answer or solve the problem. Analyze and give answer. So let's go back up a few steps to right here. We're figuring out where this thing is greater than or equal to 0. We know it's equal to 0 when x is -4 and when x is 2. And we've just figured out that it's greater than 0, positive, on this interval and on this interval. So if you put all of that together, you can say that x is an element of the interval from -infinity to -4. I'm going to put a square bracket to include that endpoint, or union for or. X is an element of the interval from 2 to infinity. Square bracket to include the 2. You can give your answer like that. I suspect in your book they're going to give the answer in more of an inequality form. So this is equivalent to saying that x is less than or equal to -4, or x is greater than or equal to 2. So the answer is correct either way. I do want you to get used to using interval notation because it's going to be used more as you go further in math. Okay, let's try another one. So here we have our inequality. Use the critical point method. So step 1 is to set it equal to 0 instead of less than or greater than. So 3x squared minus 9x minus 12 equals 0. Step 2 is to solve for the critical points, and it just so happens that we can divide both sides of this equation by 3. Be careful if you're dividing by a negative though, because that would reverse the inequality. So you have to think about that. It might be better to factor out the 3 and leave it there than to divide by it, because if you were factoring out a negative and you left it there, then chances are you wouldn't make any mistakes on the sign. Okay, now I believe this is factorable. We can factor further. We have x minus 4 times x plus 1. So then if we set those factors equal to 0, when we set 3 equal to 0, we don't get any critical points. But when we set x minus 4 equal to 0, we get x equals 4. And when we set x plus 1 equal to 0, we get x equals -1. So those are the critical points. So we're going to use those numbers to divide the number line into intervals. So we divide it at -1 and we divide it at 4. So we give our intervals -infinity to -1, -1 to 4, and 4 to infinity. Okay, we pick a number in each interval to test. So I'm going to pick x equals -2, x equals 0, and x equals 5. Where do I test it? In the factors. The first factor is just 3, so that's positive. And then -2 minus 4 is going to be negative, and -2 plus 1 is going to be negative. Positive times negative is positive. And now we have 0 to test. The first factor is 3, so that's positive. 0 minus 4 is negative, and 0 plus 1 is positive. Positive times positive is negative. And finally 5, 3 is positive, 5 minus 4 is positive, and 5 plus 1 is positive. So we have positive times positive times positive is positive. Okay, now to analyze the results and give our answer, look back at the problem. Remember we were looking for less than 0, and less than 0 would be negative. So we want this middle interval. Also notice it doesn't say less than or equal to, it only says less than. So we're not including the endpoints. Those critical points are not solutions. So we just have x is an element of the interval from -1 to 4. And if you want to write that with inequalities, we would say -1 is less than x is less than 4. Okay, let's do one more. So you might just want to pause and try this yourself and then resume and see how you did. So we want to have a 0, so I'm going to add 3x squared to both sides and subtract x from both sides. And then we're going to set it equal to 0 to solve for the critical points. Now I'm going to pause and work on this and see if I can figure out if it's factorable. Can you guess what I did to figure out if it was factorable? I did not try all the different factoring possibilities. Instead, I found the discriminant. Remember this from a previous lesson. The discriminant, b squared minus 4ac, would be 36 minus 4 times 9 times 2, and that worked out to be -36. So remember what that tells us. If you think about that as part of the quadratic formula, you have x equals the opposite of b over 2a plus or minus the square root of b squared minus 4ac over 2a. That means we have the square root of a negative and a bunch of other stuff. Okay, so that's telling you that the roots of this quadratic equation are actually non-real. That's telling us that there are no real numbers that make this equal to 0. So actually it's not factorable, and there are no critical points. That doesn't necessarily mean that there is no solution. If you think about it graphically, if we're talking about where is a parabola less than or equal to 0, well, what if that parabola is always above the x-axis? Then it's never less than or equal to 0. But what if that parabola is below the x-axis? Then it's always less than or equal to 0. So it's either going to be all real numbers or no solution. We have to figure out which. Now, since we don't have any critical points, we have no place to split the number line, so we just have a single interval, -∞ to infinity. So my favorite test point in there is, can you guess? 0. So I'm going to take 0 and plug it in to my unfactored part there. 0 minus 0 plus 2. I get a positive. Okay, now let's analyze the results. We were looking for less than or equal to 0, but we got greater than 0, so that means this problem has no solution. However, imagine that it had been a greater than sign, not a less than sign, then the solution would be all real numbers. So this one's kind of a special case. Okay, so that's the critical point method, and we have a little bit more to do in this lesson on the other two quick topics, but I'm going to end the video here and leave those for video number 2.